Dr. D here, and today we're going to learn about solubility, namely why certain liquids mix together and why some things dissolve in water. So let's dive into it in Content with Content. So when talking about solubility, the general rule is that like dissolves like. And what this means is that polar molecules will mix with polar molecules, or that a polar liquid is going to be miscible with a polar liquid, and that nonpolar molecules mix with nonpolar molecules. Now, if we're talking about a solid, generally that will get dissolved in something called a solvent. And the universal solvent is water, mainly because a lot of things dissolve in water. So let's take a look at sodium chloride, and we can see that we have an ionic bond here. And normally we're not going to see sodium chloride off by itself. It's normally going to be combined with a bunch of other sodium chlorides in a lattice structure. And we got a little bit more depth to this. And in order for the sodium chloride to dissolve, we're going to break up all those intermolecular forces between all those other species. So if we have this sodium plus and we're combining it with water, one water molecule, that's not going to be energetically favorable enough to pull it away from all those other essentially interactions it's going to have with all those other chlorines. But if we add a bunch of water, now this is going to be more energetically favorable. And the main reason for this and why water is a universal solvent is because it is extremely polar. It has essentially two sites for hydrogen bonding, and it's very, very small. And so this allows several water molecules to interact with ions such as sodium plus or whatever molecule we're referring to. Now, there is a table that kind of goes through solubility rules. And generally, when we talk about solubility rules, this is in reference to water. So if these things are going to be soluble in water or not. All right. So pretty much all of the elements on the far left column are going to be soluble. And then anything that has a nitrate, acetate, or perchlorate is generally soluble. And then we have the halogens, the chlorides, bromides, iodides, and fluorides are going to be soluble with a few exceptions. Now, these exceptions are kind of useful in that we can use them to determine if there's other substances or contaminants in our water. So like this is very useful for trying to isolate how much lead might be in our water, things of that nature. And same is true for sulfates. Again, most of them are soluble, but there are a few exceptions. Now, there's certain things that are generally insoluble in water. We have the hydroxides, carbonates, and sulfides, and phosphates. And the main exception with these being insoluble would be anything that's in that far left column on the periodic table. All those are going to still be soluble. And a handful of elements in the second from left column on the periodic table, along with ammonium ion. So these are general rules for solubility, and keep in mind that these are kind of a general rule. Now there's going to be some instances where some things don't fully break apart, or they're only partially soluble. And so the general rule is that strong acids and strong bases will completely dissolve or will completely dissociate. So if we have lithium hydroxide, this is a strong base. If we mix it with a bunch of water, it'll break up into its ions, so we'll have lithium plus and OH minus. And so we say this completely dissolves. Now, in truth, every reaction has some ability to occur in the reverse. But in this case, if we have a strong acid or a strong base, this occurrence is going to be very, very small or virtually non-existent. So that's why we say that strong acids and strong bases completely dissociate. Now, the story is a little bit different for weak acids and weak bases. If we have acetic acid here, a weak acid, and we mix it with a bunch of water, we can have it lose its H plus and form a hydronium ion, and we have to have a certain number of waters for that to occur. But the reverse reaction can occur and is actually quite a big factor in this. So only some of the acetic acid is going to lose that hydrogen. So for each individual element, you have to, it's going to differ depending on which acid or which base it is, if it is a weak acid or weak base. So I hope that you learned something. And as always, keep thinking, and I'll see you next time. Goodbye.